Hi everyone, good afternoon. So it's now 2:45 and it's the SCORE webinar on linked data by Dhaval Thakker from the University of Bradford. So we're a small group, but we should start and others can join. Please keep your microphone. So Dhaval, when you're ready.
Okay, I'm ready. Just one check, you can hear me fine?
Yes, we can hear you well.
Okay, that's great. Thank you. Let's start. Hello, everybody. Welcome to this webinar. I'm Dr. Dhaval Thakker. I'm a senior lecturer in computer science at Faculty of Engineering and Informatics at University of Bradford. And the title of this webinar is on linked data with focus on smart city solutions. And the webinar is obviously conducted as part of the SCORE Interreg ERDF project. So this is the outline of what I want to sort of talk about. To start with, three questions is what I'm trying to cover in this talk. What is linked data? Why linked data? With the focus on why linked data for smart city solutions, and how to publish as part of linked data. And while doing this, I have certain audience in mind. For first two questions, what and why, I'm targeting the decision makers, but also developers who might be looking answers for these questions. For the last one, which is a bit more primer on linked data and how to do linked data, sort of kind of a 101 on linked data. My target audience is more to do with developers rather than the decision makers. Generally, I am happy to take questions in between, but considering the format of the talk, I think it would be best if we take the questions at the end. But if you have any questions, meanwhile, do pop in the text messages window of the GoToMeeting, and I'll try to answer them at the end with the other questions you might have. I should be done just over 1 hour. I'll try to be as brief as I can so that there is some more time for questions at the end. So to start with, I want to start with what is linked data, and obviously I have a few slides on this topic. But I thought it would be best to start with TED talk given by Sir Tim Berners-Lee on linked data. Obviously, we know that Sir Tim is the inventor of World Wide Web, but probably not many people know that he's also one of the key inventors of and also advocate of linked data as well. So generally, I don't play sort of a more than 2-minute video, but in this case, it's about 4 to 5 minutes video, and I personally think it's worth it to hear him setting the context why he thinks linked data is important, and the journey to linked data. So I think you'll have to hear the video with me for the next 4.5 minutes. So if I start that.
Time flies. It's actually almost 20 years ago when I wanted to reframe the way we use information, the way we work together. I invented the World Wide Web. Now, 20 years on, Ted, I'm to ask your help in a new reframing. So going back to 1989, I wrote a memo suggesting a global hypertext system. Nobody really did anything with it very much. But 18 months later, this is how innovation happens. 18 months later, my boss said I could do it on the side as a sort of a play project. Kick the tires of a new computer we got. And so he gave me the time to code it up. So I basically roughed out what HTML should look like, hypertext protocol, HTTP, the idea of URLs, these names for things, which started with HTTP. I wrote the code and put it out there. Why did I do it? Well, it was basically frustration. I was frustrated. I was working as a software engineer in this huge, very exciting lab. Lots of people coming from all over the world. They brought all sorts of different computers with them. They had all sorts of different data formats, all sorts of kinds of documentation systems, so that in all that diversity, if I wanted to figure out how to build something out of a bit of this and a bit of this, everything I looked into, I had to connect to some new machine. I had to learn to run some new program. I would find the data, maybe the information I wanted in some new data format, and it was all incompatible. It was just very frustrating. The frustration was that there's all this unlocked potential. In fact, on all these disks, there were documents. So if you just imagine them all being part of some big virtual documentation system in the sky, then, or say on the internet, then life would be so much easier. Well, once you've had an idea like that, it kind of gets under your skin. And even if people don't read your memo, actually he did. It was found after he died, his copy, it was found he'd written vague but exciting in pencil on the corner. But in general, it was really difficult to explain what the web was like. It's difficult to explain to people now that it was difficult then. But then, okay, when TED started, there was no web. So things like click didn't have the same meaning. I could show somebody a piece of hypertext, a page which has got links, and we click on a link and bing, there'll be another hypertext page. Not impressive. You know, we've seen that. We've got things on hypertext on CD-ROMs. What was difficult was to get them to imagine. So imagine that link could have gone to virtually any document you could imagine. All right, that is the leap that was very difficult for people to make. Well, some people did. So yeah, it was difficult to explain, but there was a grassroots movement. And that is what has made it most fun. That was been the most exciting thing, not the technology, not the things people have done with it, but actually the community, the spirit of all these people getting together, sending emails. That's what it was like then. Do you know what? Funny, but right now it's kind of like that again. I asked everybody more or less to put their documents, said, could you put your documents on this web thing? And you did. Thanks. It's been a blast, hasn't it? I mean, it's been quite interesting because we found out that the things that happen with the web really sort of blow us away. They're much more than we'd originally imagined when we put together the little initial website that we started off with. Now, I want you to put your data on the web. Turns out that there is still huge unlocked potential. There is still a huge frustration that people have because we haven't got data on the web as data. What do you mean data? What's the difference? Documents, data? Well, documents you read, okay. More or less you can read them, you can follow links from them, and that's it. Data, you can do all kinds of stuff with the computer. Who was here or otherwise seen Hans Rosling's talk? When Hans Rosling's was at TED, we had one of the great, yes, a lot of people have seen it because it was one of the great TED talks. Hans put up this presentation in which he showed for various different countries in various different colors, he showed income levels on one axis and he showed infant mortality and he showed this thing animated through time. So he'd taken this data and made a presentation which just shattered a lot of myths that people had about the economics in the developing world. He put up a slide a little bit like this. It had underground all the data. Okay, data is brown and boxy and boring, and that's how we think of it, isn't it, data? Because data you can't naturally use by itself. But in fact, data drives a huge amount of what happens in our lives. And it happens because somebody takes that data and does something with it. In this case, Hans had put the data together. He found it from all kinds of United Nations websites and things. He put it together, combined it into something more interesting than the original pieces. And then he put it into this software, which I think his son developed originally, and produced this wonderful presentation. And Hans made a point of saying, look, it's really important to have a lot of data. And I was happy to see that at the party last night that he was still saying very forcibly, it's really important to have a lot of data. So I want us now to think about not just 2 pieces of data being connected or 6 like he did, but I want to think about a world where everybody has put data on the web, and so virtually everything you can imagine is on the web. And I'm calling that linked data. The technology is linked data, and it's extremely simple.
Okay, I think hopefully that was helpful in terms of setting up the context why something like, obviously talked about putting data on the web, making it open, but also he started talking about this linked data technology, why he thinks that is the right technology to make the data open or make the data available on the web. some of the things he was going to talk about, how to make that data open, I'm going to cover it. That's why I didn't, continue with his talk further. But I hope that helps setting up the context. So as he said, linked data, if one has to define, is a method of publishing data on the web so that it can be interlinked and become more useful. And hopefully by the end of this talk, you would be able to see that this is what happens when you use linked data. There are other names as well, which gets sometimes confusing. Semantic web, web of data. There are obviously some differences in those terminologies, but on a broad level, they are almost the same. So you might hear different terminology. One of the things which is known about linked data is they are vocabularies, they are ontologies, they are taxonomies, but it's more than that. It's also relationships between those terms. It's more like a graph. It is actually a graph. So if you take this example, where we are trying to describe a sensor or a sensing device, then this is its vocabulary and the relationships. What this is saying is that, say, this sensing device takes observation at a particular location, it measures a particular property, and it uses a particular unit. So it is more than a vocabulary. It gives you the vocabulary terms you need to use, but also it has sort of a relationship between those terms as well, which makes, if you start using linked data, which makes your data more structured. And obviously, we all know the structured data is better than unstructured data. And some of the benefits of this would be in follow-up slides. I think the immediate question and the one which is relevant to our project, the SCORE project, is why do we need to use that for smart city solutions before thinking about how? One of the things with this sort of solutions is that we need vocabulary or ontology or metadata for readings coming from those sensors and sensor streams, and we need to call different things, right? And we know, as I said, structured data is better. So if you take this example of somebody trying to collect the data about road traffic, they need to name things such as average measured time, speed, timestamp, vehicle count, or if it is pollution data, and then different parameters about the air quality index, weather data. You will have different parameters, and that is something, if you take linked data and vocabularies and ontologies from linked data, they provide that. So if nothing else, the linked data is useful for that purpose. And hopefully I will try to highlight a few more areas where linked data can be helpful as well. So making use of something like this, what we need to do, and the advice here is to annotate our sensor streams with vocabularies or ontologies from linked data. So when I say, annotate with linked data, annotate your sensor streams with linked data, this is one sort of a typical IoT or smart cities solution infrastructure, where you can have different devices under different protocols, which is quite common nowadays, and reading different things, doing different observations. And then, the annotation can happen at the source. So when the devices are picking up different readings and they are sending that data, the annotation can happen then. Or if you're using gateways in your systems, the annotation can be done at the gateway or fog, as often it's referred to, at that level. But more often, that annotation can happen at your data access or your database layers, your cloud layers, where once the data is collected, that can be annotated with vocabularies from linked data as well. So there are different points where this annotation can happen. So why to do this? Why annotate sensor streams with linked data? If I continue that theme, then one of the answers is sensor streams, when they are collected, although you are collecting them in isolation, so you might have one stream for road traffic data, another for pollution data, another for weather data, they needs to be integrated because there is a higher purpose. Generally, the solution you're trying to develop needs to do some sort of analysis of this sort of data. So, for example, in this case, you might be trying to find correlation between road traffic in a particular area with pollution and weather in that particular area. So that's one way to look at it. And using something like linked data makes a developer's life much more easier, in my opinion, because when the sensor streams are annotated with linked data, I do not, and using different vocabularies, then I don't need to worry about learning and working with different APIs. I have to do minimum reconciliation because the vocabularies are coming from linked data. I just need to extract data from this sources and write few queries, right? So things integration and analysis becomes seamless. So if this is something which sort of the annotation of sensor stream is something which sounds unfamiliar, and you're looking for something which is familiar, something which is done similar in the industry or in the real world, and not just in the academia, then the closest example I can give is the read snippets with schema.org. Just to give an example, what I mean is this one. So as you can see here, Wicked the Musical, their own website doesn't use any read snippets compared to if you look at this Ticketmaster link. It is using read snippets. It has a bit of metadata, a bit of more sort of information extracted from that page by the search engine when you do the search. And that is only possible because if you look at this bit of snippet, you don't need to read everything there, but if I highlight the bit that somebody has put efforts by saying that the item I'm trying to annotate is actually a music event, and as you can see that the URI is schema.org, which is one of the linked data type vocabularies. It also says that the location is actually a postal address. So they are not just strings; they are concepts, they are terms from a bigger vocabulary. By doing this, the search engine can read that page much more intelligently, and then extract this sort of information. And imagine if everybody starts using this, and a lot of websites now use this. The search engines have knowledge of those events now. That what are those events, and the data is structured, so there is a lot of things they could do in terms of searching and browsing with it. And that's the schema.org I was talking about. If you're interested in this, please have a look. There is a lot of common purpose entities which are described from event to health and medical types to organization, person, places, and so on in this vocabulary. So finally, we need to model our data, which is coming from the sensor streams, and we might use the models which is provided by linked data. So that is one of the major use of linked data in this sense. And we don't need to sort of reinvent or define our own data models or vocabularies or ontologies. They are already there. If we talk about sensors, I'm going to highlight some of those data models without going into too much detail, because there is a lot of a lot of detail there in next few minutes. So again, this is one existing model, something called semantic sensor network (SSN). ontology. And as I said, some of these models are complex. For example, this one is to do with describing sensor device and what it does while collecting this sensor data streams. So this is saying this is a sensing device. It has an input and an output. Output is an observation, which is basically is doing different observations for a feature of interest. So that could be a water level, or it could be a dew point, or a temperature, and so on. And there are sort of further complexity to this model as well. But important thing to remember here is that you don't have to use all the terminology from this model. You can just pick and choose. You can just use the one you think is useful for describing the data stream or data you're collecting from those sensors. There is a link for this as well. The other one is there is a data model vocabulary for provenance as well in sensor streams. This is to do with when you're trying to have sensor streams to watch out for an event and things don't go according to plan. Things, maybe the sensor stream didn't provide the data which you needed. Then you need to go and look at the logs into what went wrong. You need to look at the provenance, and this vocabulary provides various terminologies and ways to log those things happening in your sensor networks. And that comes from again, you don't need to sort of read this page in detail. I just want to highlight that there was a very good, excellent EU project called CityPulse. I think now it's completed. Sort of one of the partners were University of Surrey, and they have developed a lot of this ontologies which I'm talking about for annotating sensor streams. And if you are interested in something like that, that might be a good place to start for you. The use of linked data becomes even more interesting for me when I can use different vocabularies and integrate different data points. So in this image, the color indicates a different vocabulary. So this is coming from, as you can see, the maroon type of color is a SSN, the ontology I've just described a couple of slides back. So it describes observations and phenomena you're observing, but that phenomena, if it deals with the weather type of parameters, you can just describe that part of your data using weather ontology. The time you need to describe, time-related properties you need to describe in your data can come from, there is a temporal ontology for that. For location-related items, there is a geospatial ontology. So you can, as I said, you don't have to use the full model provided by a particular ontology. You can just pick and choose, and you can describe your data streams with different ontologies. This is possible. What this allows one to do is very well described by a very active researcher called Amit Sheth in here. What he says is annotation of sensor streams with linked data enables interoperability and advanced analytics for situation awareness and other advanced applications from heterogeneous sensors. So, using these different ontologies, integration of data points is much more seamless. And if I go a few slides back, sorry, I should have mentioned this. So, for example, 9 cities in SCORE all collecting the pollution data, and one of my purpose or one of the solutions we need to develop is the comparison of the pollution data coming from this different sensors within this cities, and if they all use the ontologies from linked data, then my life as somebody who is trying to build this solution for comparison becomes much more easier, because I don't have to I don't have to sort of learn different APIs to access those data. I don't have to reconcile the differences in terms of the terminology they are using, because that comes from the linked data. And what I all have to do is I have to write some Sparkle queries, some queries to do the comparison, which makes my life much more easier. Just going back to, yeah, so that is the point. I hope that is all to do with the first 2 points. What is linked data? I hope I have covered some introduction to what it is, and why linked data for smart cities solutions. And the point I'm trying to make is they are excellent for annotating sensor streams, so that you can do integration of data and analysis of the data much more seamlessly and easily. So that covers first 2 points of the talk. As I said, if you have any questions so far, please write them in the text window. I'll do cover them at the end, in addition to other questions as well. So I move to sort of the third point, which is how to publish as part of linked data, which is more to do with developers. It's more sort of a primer on linked data, sort of a 101, starting from the scratch, and giving few hints about what are the linked data principles, which is a common thing when you're trying to develop linked data, how to find existing sources. So for smart cities, I have already covered some of the places where you can go and find those ontologies and vocabularies for sensor streams. And also, I'll do a gentle introduction with some 1 or 2 examples about the query language. There is a specific query language you have to use with linked data, which is called Sparkle, which has got really good similarity with SQL, but here you're using graph data rather than relational data. So there are some differences as well, which I'll try to highlight. So again, as I said, I will start from the scratch here. Some of the things which Tim Berners-Lee mentioned about web of documents is more like a global file system. It's designed for human consumption. This is the point he was making as well. And primary objects are documents, and links are between documents or part of the subpart of the documents. And the semantics are implicit. You have to read it to understand it and make connections. So the main issue is the connection is, as I said, is implicit. Although it's about data, it's about things, it's about events, it's about people, it's about items. The connection between documents and data is weak. It's implicit. This is something Tim Berners-Lee was highlighting as well. And that because of that, doing a query like this one, show me all the news stories by US president coming from Chicago. I know we can do this, but it's really hard to do this sort of querying compared to if we focus and expose more data and build a wave of data. That's where linked data or semantic web comes into play. We need to help machines to understand the web, so they can help us to understand things, as one say. Especially if machines have access to the data about things, i.e. knowledge, then they can do better job while processing documents. So that brings me back to the same slide I used. Linked data is all about best practices and principles, which I'm going to cover in a couple of slides. And it's important to remember that they are not just vocabularies; they are also relationships. It's a graph, and this one with the sensing device I've already described. And very soon we're going to see why it is a graph, what makes it a graph as well. So when we talk about the web of linked data compared to web of just documents, the analogy is rather than a file system, it's a global database. It is designed for machines first, humans later. The primary objects are things, and links are between things. And semantics are more explicit, because what you're doing is you're using a graph to describe things. And the graph is part of a larger knowledge base, which describes other things as well, making the semantics more explicit. So that brings me to talk more in detail about what are the technologies involved in doing linked data. And if you are a developer, you can see that a lot of this from this list you might be already familiar with. Definitely with URIs and HTTPs. But I will just in case, I'll just cover them briefly what they mean in next couple of slides before I move on to RDF and other technologies which are more specific to linked data. So URIs, again, you know, is something you might be familiar with. We all know what URLs are, but URIs are uniform resource identifiers. They identify any resource uniquely, and that resource could be, you know, cars, people, places, organizations, coursework, anything you can think of could have a URI, and they could be uniquely identified. So these are examples of URIs. You know, this is a URI for me, uniquely identifying me as Dhaval Thakker. And this is a URI for University of Bradford. And we'll come to this theme back later on. But you don't always have to use HTTP for that. It could be FTP or any other sort of web protocols to describe your URIs. But HTTP is the preferred one. You know, the advice here is to use HTTP URIs, and I'm sure you are familiar with HTTP as a data access mechanism between web browsers and servers, and sort of you know, these request and response methods with GET and POST, which is again used as part of linked data as well. So that brings me to a specific technology related to linked data. Again, it's now used widely in other contexts as well. So RDF is a data format to describe things and their interrelations. So basically, you know, in linked data, you need to describe your vocabulary, and you need to describe the facts about your terms, and you need to link it to other terms. So that forms a triple. A triple in our world is a subject, predicate, and object. So that is, if you need to represent a fact, you can always represent it as a subject, predicate, and object as a triple. So this is one fact. The sky is the subject, the color is the predicate, and the object is blue. Here it says sky's color is blue. So that's what RDF allows you to do, allows you to define triples in the form of subject, predicate, and object. Okay, let me give you one more example of RDF. So this is RDF describing me as an entity or as a term. Dhaval is a type of a person, so I'm a person, and as you can see from this prefix that it is using a vocabulary or an ontology from FOF, which is a very popular ontology for a friend of a friend type of concepts and terms. Then it says my name is, again using a term from FOF. My name is Dhaval Thakker, and I am based near Leeds, which is using an ontology called DBpedia, or rather data set called DBpedia, which has got this prefix. So this is a graphical representation, because this ultimately RDF allows you to write write a graph. This is the RDF representation of me as an entity. So this is me as a subject. Dhaval type is the predicate, and FOF person. A person is an object. And if you go and look at FOA person, then you would see that there are further links coming out of it, which describes the concept of person, the term person, in much more detail. So is this DBpedia leads as a concept. So if you go and look at DBpedia leads as a concept within this this DBpedia ontology, you would see that it defines leads as something which has a population of this much amount, and also it is part of West Yorkshire, which is the county here. So you know, when I say when I use a term like leads to describe my data point, I get the benefit of all the things which is related to that particular term coming with it as well. So it's literally, you are merging the data like that. So even though you describe just DBpedia leads is my location, because the leads is described somewhere in much more detail, I can, if I want to, I can get this chunk of the data from the description of leads in this data set as well. So that comes from DBpedia, which is a big bonus when you're trying to do, you know, when you're trying to annotate your entities or even sensor streams. So as a developer, I think it's good to know that RDF is a data model, but you need a serialization format. And there are XML-based and non-XML-based serialization formats available for RDF. The first one is more to do with you know, an XML-based format. It's called RDF/XML, where you have a sort of a you have your namespaces, and then you have your subject. In this case, it's me as a person, and then you have your predicate, which is name, and your and an object, which is my full name. Then again, that is a subject, that's a predicate, and that is the object. That is a subject again as me. This is the predicate, and this is the object, which is my location. So this is just you know, this graph described, serialized as an XML, RDF XML file. And there are other formats as well. There is something called Turtle, which describes the same triple in a different format, and N triples as well. So if you are trying to use RDF data, you might be dealing with one of these formats. One I haven't included here is there is a JSON LD, so JSON linked data format as well, which allows you to serialize RDF data in a JSON format as well, which is something many developers are interested in. So that's probably, if you're interested in, that's something for you to look up. So that brings me, with that introduction to different techniques and terms you should be aware of linked data, to the main point on what are the linked data principles. So if I want to tomorrow make my data open or my data available as a linked data, how do I do it? Are there any sort of set of principles or set of steps I should be following? And there are four main steps. As you can see, they came from, again, Team Berners-Lee. The first is use URIs as names for things, anything, not just documents. So rather than using URLs, use URIs. So everything you have, your device, your readings, so your observations for your device, everything should have a URI. Not only URI, it should be HTTP URIs, because they are globally unique, distributed ownership, anything. We all know what are the benefits of HTTP and how distributed it is. It allows people, if you use HTTP URIs, it allows people to look up those names. So by using HTTP URIs for your things, so that might be for your devices and the readings you are doing for those devices, using linked data vocabulary, you're already making the data open, because HTTP by default, if you don't control it, it's going to be open. So tomorrow, if I look up the URI for your device, I would be able to see what it is telling me about. Where is this device? What are the readings, and so on. If you want to make it open, obviously there are ways you can have it closed as well. But the advice generally in linked data is to make it open and use HTTP URIs. The third is provide useful information in RDF. When someone looks up a URI, they should be, as I said, if I look up the URI of your device, I should be able to get some information, and not in any format, not in CSV format, not in XML format. It should be in RDF format. Let me just see what I have. Yeah, it should be in RDF format, and I've given some examples before about how it looks like in RDF format. To do something like that. So coming back to the third principle, provide useful information in RDF, especially when someone looks up a URI. That someone could be a person looking up that device URI, or me writing a simple program to fetch the data from that URI. Then I can get hold of that RDF and then process it in whatever I'm trying to do. Right. So just by doing these three things, it kind of pushes somebody towards making things more open. The last one is include RDF links to other URIs to enable discovery of related informations. So this is you've seen an example of this when I described Dhaval as, that means myself, as an entity. I used URI from DBpedia for leads. So I didn't say what leads is. I just use a term from other vocabulary, other data set which had already defined leads. And that is always, this is a key principle of linked data, that more you do this, that means you're making use of the data sets and ontologies other people have described. Data becomes more linked. And you can do better things with it. And the simplest is discovery of related information, right? So let me just go a little bit deeper into this. We are almost coming to the end, and almost 5 or 6 slides left now. So these links could be, I'm talking about this last principle, include RDF links to other URIs. Those links could be relationship links. So for example, it can point at related things in other data sources, for instance, other people, places, or genes. So this is what I did. I had a relationship link, and I linked to the leads as a city described in DBpedia as a data set. So don't define your own. If it's already there, make a relationship link. So this is an example I just talked about. This is what I did. And that means I have benefit of all the data which is there in that data set, in that ontology about leads, something which I've covered before. It could be identity links as well, because what might happen is that you might miss out that there is somebody else who described what you wanted to describe, maybe better or differently than what you wanted to describe, an entity. Then later on, when you realize, you can say that it's same as, so what I described here as a Ghent as a city is the same as somebody else has described Ghent as a city, for example. So this is an example from my local hometown. A Kirkgate market is described in DBpedia, but it's also described in another data set or ontology called Freebase. And if I just have this link, then basically just by doing this, I can also fetch the data which is described here, and I can merge the data with the data I have about Kirkgate markets. And this need exists to have a sort of identity links, is because there might be difference of opinion. People want to describe things differently, traceability, and also if you have multiple or multiple data sets like this, no central. You can use the existing vocabulary to further specify yours. So you might have already defined what a small, medium enterprise is. But then you can say that, there is already a data set or an ontology, and I want to say that what I've described as a small and medium enterprise is a subclass of, that means it's a subcategory of what this ontology is describing as a company, or this one as a business, or this one as I don't know what that is. But that's another lesson. Sometimes it's good to use the real names rather than the sort of a lot of people use UUIDs. But yeah, you can have existing link to existing vocabularies and to further specify what you mean by a particular term. So this is the summary. Already covered that we should use HTTP URIs. We should provide useful information in RDF when somebody looks up a URI, and that could be a person, or it could be a program which is querying that URI, trying to fetch some data about it. And it's always good to include links to other URIs, other vocabularies, because the link data thrives on this sort of links, and I'll show you an example very soon of this. Okay, we talked about RDF serializations and also links as well, so I'll not repeat that. So I think last 2 or 3 slides now. So the images question is, I want to use the existing vocabularies from link data. Where do I go and find it? Obviously, I already described some for sensor streams in this slide, but believe it or not, a lot of people have followed these principles, and they have generated these vocabularies and data sets using these vocabularies and made it available, and they've also gone in extra effort of making links with other data sets and other vocabularies as well. And all this is available as a giant global graph consisting of billions of RDF triples. I showed you some 5 triples in while describing me, Dhaval, as an entity. There are billions of such triples which are available. And the place to go is one of the places to go for this to see what is available is this one. The URL is lodcloud.net, where they've done a stellar job of sort of creating a graphical representation of what this vocabularies and data sets are about. So which domain they belong to. So it's color coded. Some are from geography. Some are linguistics, media, publications, user-generated, governments, and so on. So each of this bubble you see here is actually a data set using link data principles, which somebody has published, generally an organization, but in some cases, public as well. So there are many, you can see bubbles, many. There are about 1,200 plus data sets available in this sort of different domains. And the links you see is what the point I was making. You have to make it proper link data. You have to try to make links with other data sets. So this links you see is this data sets doing extra effort and making link with other data sets. And you can see that this is more dense. There are more links between these data sets than there is the one which is in the outer sphere. Yeah, so one of the ways to go and see what are the data sets which are available for your purpose is to go to this one and then drill deeper and try to find out a bit more about those data sets and see if these vocabularies are fit for your purpose or not. So in terms of numbers, as I said, there are billions of triples. Again, you don't need to sort of read the whole all the numbers, but the one which you need to again, this is the first one I want to highlight is this is a bit outdated, 2011. There were 295 data sets in different domains, as I said, and 31 billion or so triples. I don't have figures for 2018, but I know that there are 1,229 data sets out there, so it's almost 4 times than probably 7 years ago. So there is more triples, you can say. And if you don't want to sort of go to that graph and try to sort of browse through it, because that could be time consuming, you can head to sort of a portal which sort of hosts the metadata about this vocabularies and data sets from linked data, something called datahub.io, which allows you to do free text search to find those data sets. So they are also aware of all the data sets which were there in that giant graph as well, and they provide metadata and some information, some examples of what sort of data, what sort of vocabulary is there before you spend more time looking at its suitability for what you want to do. Okay, so that's the website. Sorry, I thought there were only a few slides, but I think there is now. Okay, there are a few more. But what I'll do is, keeping up with the time, I might not go into a lot of details, but just highlight a few things which you can explore further. So one of the data sets within that graph is called DBpedia, which is literally taking this info boxes you see in Wikipedia and converting that into RDF data, this graph data, following those linked data principles. And if you want a general purpose data set or a vocabulary, DBpedia might be the best place to go to. A few slides on the query language, because we're talking about a graph sort of data, RDF data, based on RDF data models. So there is a specific or a different type of query language for this sort of data, and it is supported by all major RDF databases. So when you're hosting this sort of data, you have a RDF database, and all the major databases do support Sparkle. It is a W3C. I'm not sure whether it's a standard, but it's definitely a recommendation from W3. So there is with a query language, obviously you have a structure, like SQL has a structure, Sparkle has a structure for the query language as well. Again, you don't need to look into too much detail on this slide, but there is a lot of similarity with SQL. For example, you have a select clause, where a clause, also from. In case of from, it would be you have to specify which data set or which vocabulary you want to query. You need to define all your prefixes, similar to what you do in your XML files. And all those things, order by, group by, is also available. Maybe this will make even more sense when I show you a couple of examples. The difference comes what you put as part of where clause, because what you're doing is you're querying triples, you're querying a graph, and that's where the difference comes. So let me jump on to an example for this. Yeah, and as I said, there would be endpoints where you can query. This is similar to your PHP MyAdmin type of thing, where you can sort of query your data sets or the vocabularies before you integrate that as part of your API. So there is one for DBpedia as well, which we'll use to show some of the examples of Sparkle. Right. So this is one query. Again, a lot of detail there. I'll just highlight the bits which are important. So here we are trying to find out, DBpedia, as I said, is a general data set. It is literally a queryable version of Wikipedia, so that you can query rather than just going and reading it yourself. So this is one example of what Tim Berners-Lee was talking about, rather than having just a website and documents. If we can have that data extracted and converted into something like linked data, then you can query the data, query the knowledge which is there in that data set. So here it's saying somebody who is astronaut and retired, find them and sort by youngest first. So then you have your select, and from, you specify the graph. So that's why you have to give a URI. Everything is URI in linked data world. And then you have to give a query pattern. So that's where this triple and this graph differentiates it from the relational databases. This one is saying that somebody who is a type of astronaut. So there is a triple already. This is the subject. This is the predicate. This is the object from RDF. Whose status is retired. and their birth date should be ordered by their birth date. And because these are three sort of graph triples, one after another, this is a joint query. So that means anything which is there in the data set has to match all of them. So somebody has to be person, has to be astronaut, has to have a status retired, and also has to have a birth date against their name in order to qualify for one of the results here. Right. So this is what it returns when I fire that query. This query against DBpedia endpoint. It returns me this results, and you can see Buzz Aldrin is also there. So astronaut retired, youngest first. There is a different type of query as well. If you want to just ask a question, because these are data sets, they contain knowledge. Imagine if you want to ask, if once you store your sensor data somewhere, and if you want to ask a question or check something, you can use a different type of query mechanism, something called ask. In this case, I'm asking, is India a landlocked country? You don't have to specify where. You're just saying that India, is it a type of landlocked country? And it will return true or false as a result. And obviously, in this case, it's false. So that's your a very sort of a bird eye view of linked data, but also Sparkle as a query mechanism. And hopefully it gives you some idea why linked data is a way of publishing and interlinking structured data on the web. I also cover linked data principles, which are very easy to remember and very simple: HTTP URIs and RDF data, and make sure that you provide, when somebody looks up that URI, you provide the RDF data, and also try to link to other data sets, other vocabularies you are aware of as well, because linked data thrives on that. I've also covered a bit of how to find existing data sets in Web of Data, that graph, and also that website, and also a brief introduction to Sparkle. That's it. Before I end, I just want to have a quick acknowledgement to Payam Banaki from University of Surrey and his CityPulse EU project team. I've used a few slides and diagrams and so on from their presentations in mine. Thank you.
Thank you, Dhaval, for this really interesting presentation. I think now it's time to open the floor for questions. So whoever has a question can unmute himself, and one by one, so Dhaval can answer.
I've had this small question, maybe remark. You've mentioned that the HTTP is a preferred protocol, but I assume it's HTTPS now, or what do you think?
I'm not too on the top of what update has been done on the principles of linked data, but I guess if you're looking for more secure sort of a protocol, obviously HTTPS would be the one to use. I think more important point is if you start using HTTP URIs, then you naturally you are making the data open, right? Which is for public services, that is I guess my guess is not a problem, and actually that is the intention. So yeah, HTTP or HTTPS. Sorry, I'm not fully updated whether it's HTTPS is the recommendation, but either of them will naturally make things open with linked data.
Okay, thank you.
I have a question. Hi, this is Klaus here from Max Company. I'm kind of, as a non-technical person, I'm really interested in understanding how can cities or public authorities ensure that the data they're buying or producing or using is also linked data or linked open data. So is this perhaps a question to the cities in the room? Is this something you try do? And if so, is it something that kind of your institution promotes? Or is it something that you just as a conscientious developer do?
Well, I might try to answer that, given that, I'm one of the cities in the room. This is Tua from Aarhus speaking. I don't think that any of the open data sets that we publish currently are published in any linked data format. And I don't think it's currently something that the city has a large focus on, if any focus whatsoever. As a developer, I've been aware of the concept of linked data, obviously, for yet the better part of 2 decades. But apart from the World Wide Web, I'm still struggling a bit to see. I haven't seen sort of the marketplace success yet that sort of truly has convinced me about its usefulness.
Okay, can I just add something? I think, I'm not going to try to convince somebody who's been working on or looking at this for 2 decades. I've been looking at it as well, and I can see where the sort of skepticism might come from, because it has not been as successful as we would have hoped. But I think there are a lot of success cases, and there are not many which are known. I think that is what or they're not that open about using it. Google being one. The schema.org is definitely, they don't call it linked data, but it is. We know that. So I agree with but one of the remarks I was going to make, rather than trying to convince. Obviously, that's not the purpose. Is the Aarhus was the part of the City Pulse project, and a city of Aarhus, and there are few data sets which were published. I think it was one of the, if I'm not incorrect, it was one of the more sort of active member working with Surrey to publish some of the data open. So, and again, I know, I work for university, and different people might be doing the same thing, and I wouldn't know. So might be, there might be different corner of the city who might be part of this project, and they might have done some work. But well, definitely there is. If you look at the City Pulse website, there is a lot of data sets which came from Aarhus.
Yes. 2 things. I just so we are clear. I think you're the expert here. I'm not saying I've been working with linked data for 20 years, but as a developer, it's a field that I've been following loosely, because I'm really intrigued by the potential. I also agree with you. I both agree and disagree with the schema.org, because this is one of the things that we when we do web development, that we look to and that we use, because we're aware that it can give Google or Facebook or whatever a much more informed way of presenting data and interpreting data. But at the same time, given the size of Google, given the size of Facebook, given the potential here, I'm also a bit underwhelmed by the degree to which schema.org has gained traction on the web. And I've also, just through personal interest, followed a few sub-issues when it comes to schema.org, where it becomes really slow and tedious, this whole process of defining the vocabulary and standardizing the vocabulary. So that's one of the big challenges that I see with linked data and with initiatives such as schema.org, that how, you know, at least initially, or for the past, what, 20, 30 years, the web has sort of powered or thundered out. Just, you know, it's been this crazy uncontrolled space for innovation, but having standardized vocabularies is sort of a bit at odds with this uncontrolled innovation space. And yeah, so that and yes, and on the CityPulse thing, I wasn't personally involved, but I know we were part of it, and also we're now part of another project that is called IoT Crawler, where again Surrey is also a partner, and where we are. One of our rules is to try and prevent or give them as many data sets as we can to assist them in their work. But if you look at our sort of normal, we publish data on our sort of standard open data portal, when we're not asked by, you know, for specific things, then it's just the standard CCAN and it's just standard CSVs, and it's, yeah, and the linked data sets, unfortunately it's not a focus in the daily work and the daily publishing of data sets.
Yeah, I think that is I think both are remarks rather than anything. It's, yeah, I agree. There is a bit of extra effort involved, bit complex effort involved in making it linked data. So that might be a bit of barrier in that. The second is the comment you made about the schema.org. Again, it's a philosophical debate. The world of linked data, we want things to be decentralized rather than centralized, because with vocabularies, it's difficult to centralize and get everybody to agree on something. So, you know, decentralized is what the linked data world lives on. You know, you define, if you think you don't agree, then you define yours, and we will have some sort of alignment. That's what they go with. But it's just a remark. Yeah. Thanks.
Another question, if nobody has one, is that, you know, one of the things we've been looking at, again, that I'm only just learning about, but because I see the potential of linked data with, you know, traditional data sets, or rather I see how you can link, say, documents, how persons are linked, how institutions are linked. But a lot of the work in SCORE and some of the work we're also doing outside of SCORE is all of a sudden in the IoT space. And now I see people talking about linked data for IoT. But I haven't seen any examples as to what would define a link, say, between two sensors. Or, I mean, I'm struggling personally as a developer to see how the concept of links applies to the IoT space. Is that something that you have seen as part of your research? Is it something that you can talk a little bit about?
I think you're right. This is still a new thing, to be honest. Using it for IoT, so there are not well, IoT world is in every sense is sort of new in a lot of sense. You know, to see a lot of successful examples, and bringing the linked data on top of it is I haven't seen many. I've seen in academia, CityPulse being one, and there are a couple of other EU projects who have done that, where where they have, they always focus on the sensor streams and converting that as linked data, which is what I presented here as well. So I can only talk about the potential, which the example I gave was the comparison of, if let's say all of us want to do the air quality, if we use vocabularies from linked data to describe our sensor streams about the air quality, then the comparison, storing that into a RDF database and firing Sparkle query is very seamless. It's very easy to do, right?
Okay.
So I can only talk about the potential. Yeah, this is still sort of a developing field. Yeah.
Okay, thank you.
So we have a question from Tim from Digipolis as well, who's in a busy space and can ask a question. He's asking, so it made him think of Wolfram Alpha. Everyone's wondering whether Wolfram Alpha is also queryable by kind of a linked data approach.
Sorry, was that for me?
I guess so.
So sorry, what was the question?
It's in the chat. It's about so about whether Wolfram Alpha is also queryable. Not sure if you're aware. Can you see it in the chat, Dhaval?
For which also has index levels information. I was wondering if I'm not too sure. I haven't looked at that data set. I can come back to. I can come back to you. Sorry, Tim. Sorry, I'll come back to you. Yeah, it will not take long for me to find out. Yes. Yeah, that's the one, the Aarhus data set. This is the right link, yeah, the one you have, yes.
Any more questions or input from Digipolis? What does linked data look like in Digipolis?
So if you go to data.stad.gent, you can see all our data.stad.gent. Okay, I messed it up. There you can see all data sets we have here. No, stad.gent. First city and then .gent. We've got our own TLD.
Data.city.gent, is it?
No, data.stat. I'll type it here.
Okay, this is a difficult thing to try live. Okay, all right.
There you can see the data sets we have. And if you click on the link on top, data, there you will find the data sets, and then you can select on the left. You scroll a bit down, and you will see that there's data in the Virtuoso data sources. You have the data tank, and then you have the Virtuoso Gent. That's just off screen. Yeah, there, 41. There you will see the data sets we've produced as linked open data, and you click on that, and then you can go to the Sparkle thing where you can query that data. So we've got our own Sparkle endpoint. So a Sparkle endpoint is sort of like an interface where you can paste your queries, and then you can get the responses back. This is the sort of, let's put a human in the middle, just to have a quick test and a quick view of the data we expose this way. It's been like a few years we're working on linked open data. I've seen that it has some benefits and some drawbacks. One of the nice things I think about linked data is that you can specifically query the data you want. We've also got other data sets, let's say the the landing in the library. We got some numbers on that, and then you are free to download data sets from, I think, 1 gigabyte each. And here you can specifically query the data you want. So this removes a bit of overhead. On the other side, we see that if you open up data in another way, so you give them basically a file or a table, the business case is very clear. We've opened this data for this goal, and you will use it for this goal, and it takes some interpretation and some programming to make it to have the data come out. The data set has one specific subject. It's about the dog toilets in Ghent, for example. So it's very limited if you do it in the old way, but that also makes it very clear for the users. And even the developers who are integrating that, they say like, okay, I need a data set of the dog toilets. I'm going to build a dog toilet app, so I'm going to get that data set there. And here you will see that you get this graph, which is a sort of more broad, more flexible concept, but then it's less clear to the people or the users, and by users I mean developers, on what can we do with this. So opening linked data as such is very good, is essential, but it's not the end goal. It's not the end goal. You know, you will still need to provide for all interesting cases and business cases. You need to provide example queries. You will need to write maybe blog posts or examples or what you can take out of this. So it's nice that you just link all the world's data together in one big graph, but that tends to confuse people a bit. So these are just my random thoughts on the subject.
One question, Hans. Do you have any stats on, I guess your data might be available in multiple formats, linked data being one.
Yeah.
Do you have any stats on different data sets and what sort of formats are widely used by your sort of clients? That means citizens and developers and businesses.
I'm not sure, but I will look into it for next time. I'm not sure if we've implemented statistics on the Virtuoso server. I kind of doubt it, but I will look into it.
Okay, thank you.
Great. I'd like to ask a quick question to Tino. Tino from Hamburg. Is kind of linked open data something you're implementing in the Geoinformation unit? Do you have any experience with it, and how is it going?
Sorry, again, is that question for me?
Oh, sorry, it was for Tino from Hamburg.
Oh, okay. It is from Tino. Is it for me?
Oh, sorry, it's for Tino. Let's see if Tino can respond. Oh, okay. So I guess Tino is not unable to chat right now. Any further questions from anyone? Dhaval, would you mind speaking? A quick question to you, Dhaval. How can we then now follow up on this work? So it seems to me that the linked open data is an extremely important principle, at least from my outside perspective. So I understand that some cities in SCORE have quite some experience with it. Some have maybe tried it and are not fully convinced. So what will be the next steps in kind of continuing this discussion on the community?
I think this is, I mean, people who are not convinced have a reason for it. It has been, some cases has been very successful and some cases it's not, because there is a learning barrier, there is a publication cost attached to it, in the sense it takes more time to do linked data than just CSV, or other formats sometimes. So I think I thought about it, and I thought that, you know, more success or more examples, at least we can show as part of this project, us being a starting point, whatever we try to do, if we have that data, or people we work with, if try to convert that data in linked data to start with, if we have at least 1 or 2 demonstrators, examples of it, then that would be a good starting point, because we need a starting point there. And Agent has done a great work, you know, a lot of work there as well. But we also want to contribute from University of Bradford. So the citizen science app we are doing, we want to have that data as a link. We're going to do with some of the partners. We hope that we would be able to do that as a linked data as well.
I'm very interested in further developing linked data, but I'm also curious on the feasibility of using it for sensor data. So I get that the triple, the predicate, like I work in Ghent, I was born there. Then I don't see the time flow. Like okay, we've got a sensor here, and the only job of the sensor is every 5 minutes he calls back to say that okay, the traffic light is still working. So I don't see that happening.
I think that's where we want to sort of provide some examples of that ourselves in the project. It's about picking the right vocabulary, like with other domains you have done, and sort of try to integrate the data using that vocabulary. So that's where I think the strength comes out.
And then the other aspect that we want to develop more, and that's very, very practical, is still the taxonomy tool, since linked data is always linked to taxonomies, and to make these taxonomies visible, to get them operative in our company. We are researching a taxonomy tool. And it would be nice if this can be a shared effort between different cities, particularly because the taxonomy tool removes the boundaries of language. So we take a concept, let's say water level, and then we translate it into whatever word you want, and we can still have the same concept to interface with. And it does not matter that you call it water level or something like that.
Yeah.
I see 2 comments in the chat on the IoT register challenge that might be useful there. It is now 2 to 4. So I think this brings us to the end of the webinar. So I'd like to thank everyone for joining, and of course Dhaval for a very great, kind of quite inspiring presentation, I would say, or inspiring webinar. As usual, this whole thing is recorded, so we'll post everything on the community, and it'd be great to also see this conversation continue over the next few weeks.
All right.
Yeah. Thank you very much, everyone.
Okay. Thank you.
Thank you very much. Just one point I'll make is, webinar is a very difficult sort of a medium, because you don't have people in front of you and you're just talking to yourself. So I hope it was not too bad or boring. I hope you found it useful. Yeah, thank you.
If you're talking to yourself anytime, please broadcast it. It's very interesting.
Thank you.
Thank you, Dhaval.
Yeah, thank you. Thanks, everyone.
Thank you.